So what we're going to be learning about today is how to graph radical functions. We've done a bunch of stuff with radicals. We've simplified radicals, we've multiplied and divided radicals, we solved equations with radicals, and now we're going to graph them. It's kind of the end of each section. We graph the thing that we were working with. Now, you guys have actually graphed radical functions already, because radical functions are just simply square root functions. And at the beginning of the year, you had to memorize all the parent functions, and this one was y equals the square root of x. But the reason it's back in here at the end of the year is because we figured you probably forgot. So we're going to graph square root functions, and then we're going to identify transformations, which are the same x is y, just like they always have, kind of thing that we've been working with all year. Now, when you first learned these, you did not have to do negative functions or vertical stretches. I kind of took that out of the test, but you needed to know what it was in an equation. For this section, you'll actually be doing those kinds of transformations. So let's get started. All right, so graph the following and state the domain and range. So first thing we're going to do here is just look at the normal square root function. And to do that, we're just going to plug in numbers into x. So if f of x is the square root of x, here it's asking me to find the square root of 0, square root of 1, square root of 4, and square root of 9. Hopefully you don't need a calculator to do any of these. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So now I'm going to go to my graph and I'm actually going to plot these dots at 0, 0. Oh, my dot not very big. At 0, 0. At 1, 1. At 4, comma 2, because x is my 4, comma 2. And at 9, 7, 8, 9, at the very end of my graph, comma 3. So if I connect those dots, I've got a function that looks like this, and it's going to keep going in that direction. Now you'll notice this function is going up. From here, it goes up and up and up and up and up and up, and it's actually going to keep going up and up and up and up, even though it starts to do it really slowly. So for our domain, we're going to say how far left to right does this function go? And if I look, how far left do I go? I go all the way to 0, left to right, if I'm looking this way to this way. But 0 is in my domain. We see they have this point here, 0, 0. So that means I have to use a bracket here to include 0 in the range. And then how far right does it go? Well, I see this arrow pointing all the way off to the right, so it's going to go all the way to positive infinity. And then for the range, it's how far low to how far high. And again, y, 0 is included in our range, but that's the lowest this thing goes. And then how high does it go? It goes all the way to infinity. Notice because it's our square root function, we don't have anything in the negatives for the y or the x. It's because I can't take the square root of a negative number. It becomes imaginary. So I don't actually get square roots of negative numbers. That's why there's no negatives on the graph. So this is our square root function. This is what it looks like. This is our starting point. Okay, so now we've been given some graphs, and all it wants us to do here are state the transformations. So looking at that first one, g of x, there are 3 things that have been done to this function from our normal just g of x equals square root of x. The first thing we notice is there's a 2 on the outside. That 2 is being multiplied, which means it didn't move the graph up or down, but it actually stretched it by 2. And all the stretches that I give you are all going to be vertical stretches. So we never have to worry about is it vertical or horizontal. It's always going to be a vertical stretch. So we've got a stretch of 2. And then next I'm going to move on to that negative 3 that's under the radical. That means it's with the x, and we know x is lie. We also know that x either moves it left or right. But x's lie, so a minus 3 is going to move it right, because we think it would move it left, but it's lying. So right 3. And then the minus 2 on the outside is either going to move it up or down. But this number is not an x. It's not with the x. It's just out here on the outside. So it does what you think it's going to do, and it's going to move it down 2. Our next equation, we've got a negative sign as the first thing I notice. And that is actually going to flip it from this way to this way. So this is a flip over the x-axis, and just like you'll only ever be given vertical stretches, you'll only ever be given flips over the x-axis. So it flips over the x-axis. We've got this number underneath my radical that is lying to us, so just like this one went right 3, this one's going to go right 2, since it's a 2 instead of a 3. And then that plus 1 either moves it up or down. It does what we think it's going to do, so it's going to move it up 1. And then finally, we've got h of x equals negative 3, x minus 2 under the square root, and a plus 3 on the outside. So there's actually 4 things that have been done to these. See if you can figure out what they are. Pause the video for a minute and go ahead and write down those 4 things that happen. Okay, the 4 things that are going to happen here, we've got a flip because of the negative. We've got a stretch of 3 because of this 3 being multiplied and because of that negative sign. We got right 2 because of the minus 2. And we've got a plus 3, which means it goes up 3. So those are our transformations, and we'll see on the next slide. These notes are really, really short today because we've done a lot of this graphing stuff before. This is the same 3 examples on the next slide, but now we're actually going to graph them. So we're going to be graphing things with stretches and flips and stretches and flips. Okay, so now we're actually going to graph some of these equations that we talked about before. We've got 2 times the square root of x minus 3 on the inside and minus 2 on the outside. And we've already identified these transformations in the previous slide, but this again, 2 means a vertical stretch of 2. And the minus 3 means right 3, because x is lie. And the minus 2 means down 2. So the first thing we're going to focus on here is our stretch of 2. We're going to build an XY table to do that. Always, always, always graph your stretches and your flips before you do any of these rights and downs, because we can do those on the graph pretty easily, but the stretches sometimes get to us. So we're starting with x coordinates that we know the square root of, just like we used in the table in the previous slide. In previous slides. It's just like our parent function. So we have 0 and we have 1. And then I'm not going to use 2 or 3 because I don't know the square roots of 2 and 3. So I'm going to skip to 4, which I do know the square root of, and then I don't know 5, 6, or 7, so I'm going to skip to 9. So first I'm just going to take the square root of these numbers since our function is square root of x. So I'm going to take the square roots of all my x's. So I get 0, 1, square root of 4 is 2, square root of 9 is 3. Now to do a vertical stretch, if I'm thinking vertical stretch, that means it's pulling it up and down because it's stretching something vertically, and vertical is up and down. So when I think about, well, which coordinate should I manipulate to do this, it's got to be my y coordinate because the y is the axis that goes up and down. So what I'm going to do to stretch it by 2 is I'm going to multiply all my y coordinates by 2. Hopefully this is kind of coming back to you from the beginning of the year. So 0 times 2 is 0, 2 times 1 is 2, 2 times 2 is 4, and 3 times 2 is 6. These are our new y coordinates. So these 0, 1, 2, and 3 don't exist anymore. Now our point is at 0, 0, and 1, 2, and 4, 4, and 9, 6. Now we can plot those points, but then we also have to remember to move them right 3 and down 2. So 0, 0 is not that interesting of a stretch because when I graph 0, 0 and multiply it, it's still a 0. So what would have been at 0, 0, right here, is going to get moved right 3 and down 2. So I go right 3, down 2, and I plot that new point, and that's where my red dot is finally. Then I'm going to go to the point 1, 2, and it would be right here, except I've got to move it right 3 and down 2, so now it's right here. I'll get rid of those movement lines. And then I've got the point 4, 4, which would be 1, 2, 3, 4, which would be right there, until of course I move it right 3 and down 2, and now it's over here. And then I've got my point 9, 6, so 9, 4, 5, 6, and then we'll actually go off the graph a little here, right 3 and down 2. And that point will go right there. Then when I connect my dots, and just draw a line through those dots, you'll notice that this graph is a little bit steeper than our square root graph. Our square root graph looks something like that. This one's twice as steep because I multiplied it by 2. So, last thing it wants us to do is to state the domain and range of this function. So talking about its domain, that means how far left. Now it's really important to know the coordinates of this dot because it kind of controls the whole graph of how far left and right and up and down the graph goes. And we know this coordinate is 3, -2. So the domain is the furthest left the graph goes, which the furthest left the graph goes is 3, so my domain is going to start in 3. I put it in brackets because it's included in my domain. It's a dot. It's actually there. And then it goes all the way to infinity. My range is the lowest my graph goes, which is -2. And I put that in solid brackets. And it goes to positive infinity. I don't put infinity in brackets because I can't contain infinity. I can't ever stop at infinity. So I put it in parentheses to show that I didn't actually get to infinity. That's just where I'm headed. So that is your first g of x graph. Okay, this is the second example on that page. I just went ahead and moved it over some so that I would have enough room to write. This is negative x minus 2 on the inside plus 1. So we already said the transformations. The negative makes it flip. The minus 2 on the inside says go right 2. And the plus 1 on the outside says go up 1. So those are the 3 things that we've got to do to our graph. Now a flip is simply just saying if it was at 0, 0 is not going to change because I can't make that negative. If it was at 1, 1, now it's going to be at 1, -1. If it was at, we didn't use 2 because that doesn't have a nice square root. But if it was at 4, 2, now it's going to be at 4, -2. So all that happened is all our y values became negative. And if it was at 9, now it's going to be at -3. Now, beyond just flipping it, we also have to move each point right 2 and up 1. So first, with my 0, 0 point, I'm going to move it. It's always at 0, 0. Right here at 0, 0. But then I'm going to move it right 2 and up 1. Again, I'm doing my best to see this graph because the lines are really blurry. And that's where that point is going to be. Then I'm going to go to my point that is now at 1, -1 because it got flipped over the x-axis. So it's now here because my graph was this shape. Right? So this is what I'm shifting now. So my point was at 1, -1. But then I'm going to, so that's where it was. Then I'm going to move it right 2 and up 1. And I think I drew mine a little too high. It should actually be right there on that x-axis. Hopefully you guys are counting this better than I am. And then our last point that we're going to draw, it would have been at 2, -4 since we flipped it over the x-axis. But I'm going to take what would have, sorry, I meant 4, -2. what would have been at 4, -2, and I'm going to move it right 2 and up 1. That should be about right there. I'm going to start at this top blue point right here, because that's where my graph starts. And since it's been flipped over, it'll now look something like that. Kind of missed the mark on that last blue dot there. But it's now flipped the other direction. And our 0, 0 point, I'm going to put that one in red because it's really important. Our 0, 0 point went right 2 and up 1, so its coordinates are now 2, 1. Because it went right 2 and up 1 from 0, 0. That point is so important because the next thing our question asks us is what is the domain and what is the range? So our domain is how far left it goes, and we know the furthest left it goes is not -2, but just 2. And the highest it goes is positive infinity. The furthest down it goes. Now when I think about this graph, the range can get a little tricky here because this graph goes all the way down and it keeps going and going and going and going down. From here, goes further down, and it's going to keep going down and down and down for the rest of forever. Which means the lowest it goes is -infinity. And you guys get in the habit of writing it goes from 1 to -infinity. But that's just backwards because -infinity is smaller, and we've got to put our smaller value first. So my range here would actually go from -infinity to 1, not 1 to -infinity. You've got to start at the bottom and go to the top. So our range would go from -infinity, comma, and then the highest it goes to is this point right here. The highest it goes is 1, and I put that in bracket because it actually touches 1. So be careful when you do those flips on your range. You've got to start with the lowest value, even though it's not the value that's furthest left and you're used to left to right. So that's the domain and range, and that's how we're going to graph f of x. Okay, I tried to get a little bit better picture of the graph here so I can see what I'm doing a little bit better. But this last one is our one with the most transformations. We've got a flip, a stretch of 3, and remember the negative tells us flip, 3 tells us stretch of 3 because it's being multiplied. This shift tells us right 2 because x is y, and this shift tells us up 3. So that's what's going on here. Now we're going to create this xy table again in order to take care of that stretch. Now the nice thing is we notice it's not just a 3 that's being multiplied, it's a -3. So if I take all my y values and multiply them by -3, that's going to take care of the flip, and that's going to take care of the stretch of 3, and then from there we can just take all our points and move them right 2 and up 3. So going back to our table, we're going to use our normal x values of 0, 1, we're going to pick 4 because that's got a nice square root, and we're going to pick 9. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. These are our basic numbers. Now because we've got this vertical stretch of the vertical stretch of -3, we're going to multiply each of these y values by -3. So this is still going to be 0, 0. This one's now going to start off at 1, -3. This one's now going to start off at 4, -6. And this is going to start off at 9, -9. Alrighty, so my point I'm going to use the highlighter here so we know these are kind of phantom points. It's at 0, 0, but I'm going to move it right 2 and up 3. So I'm going to count with my pencil, right 2, up 3, and now that point is going to be at 2, 3. It's going to be right there. And I'm going to erase that phantom point. It's not really there anymore. And I'm going to draw my next phantom point, the one that's kind of in between, at 1, -3. So it would be right there. I know that's kind of a big dot, but it would be right in the middle of that dot. And except we're going to move it right 2 and up 1, 2, 3. So now it's going to be at the point 3, 0. Go ahead and keep doing this with all your points. Same way. So I've got a point at 4, -6. So I go right 4, down 1, 2, 3, 4, 5. So it would be right there in the middle of that highlighted area. Except then I move it right 2 and up 1, 2, 3. And it would actually be right there. And then my last point would be at x is 9. And then y is -9. And then as I go to move this right 2, it actually goes off the graph a little bit. So if you don't draw this one, that's okay. Because I can see the shape of my graph now just from my points here. And if I just trace those with my pen, knowing that it would keep going down that way, then this would be my square root curve. So last thing we got to do is talk about domain and range. Domain is going to be how far left it is. So how far left does this thing go? Well, we know this 0 point, that's really important, is at 2, 3. So the furthest left it goes then would be +2. So our domain is going to start at 2, which is actually included in the domain, go to infinity. The range is going to be how far down does this thing go. Again, this one's flipped. So how far down does this graph go? Well, it goes from here all the way down, and it keeps going down and down and down. It's going to keep going down. So that means this graph goes down to -infinity. That's the one I've got to put first because it's the smallest. And then the highest my graph goes is in this point right here. The highest it goes is 3, and I include it. Okay, that's all we've got for today. Hopefully this, I know it was kind of a short lecture, but hopefully it went okay for you because you've already seen this kind of stuff before. We just had to throw in the vertical stretches and the flips and actually graphing these things. You have a homework assignment. Please be working on it and be focused on what you need to do. Sorry these videos are so dorky, but hopefully you learned something from them. So get working on your homework, and I'll see you guys either Thursday or Friday.